It's 10:44 p.m. January 7th. Here's my little knot diagram, and I thought let's change it around a bit. I thought, what if this little loop moved into this loop, which is inside of this third loop? What if that all moved up to right here? So then I said, well, let's draw some knot notation to represent that. And I drew the knot notation here, then I drew the knot. So you can see, here's the loop, in the loop, in the loop, inside the knot. And then I wrote out the knot notation in extended Gauss code, which is 1, 2, 3, such and such. Then I thought, well, let's try to make that knot. And here's my best attempt. Right here, you can see the loop, in the loop, in the loop, inside the trefoil knot. And then I laid that knot on my page. Which is right here. I wrote down the knot notation in extended Gauss code. It goes +1, +2, +3, -3, -2, -1, +4, -5, +6, -4, +5, -6. Then I wanted to compare that knot notation to the other knots, so I wrote it down. Then I thought, well, are they the same? So here is the last 6 digits of the imaginary knot, and here is the last 6 digits of the physical knot, which is this one. And they're slightly different. Sorry, we're not looking at that one yet. We're not looking at that line yet. We're comparing. Here's the knot that I made, and here's the physical knot. They're different. Did I want to understand that? So we looked at the knot, and I thought, how can I change it? I drew the knot without the 3 loops. That's it here. The 3 loops are here, my fake knot. Then I thought, well, we got to change that. So we took this border here, and we did a transformation. We just flipped this around to this side, so it comes around this side. Just erase this right here. You got to picture it right here. Then I thought, well, in the fake knot, the 3 loops are right here. You can see them right there on the side, right here. And I thought, well, where are they on the real knot? And here's the bunny ears. They're crossing the bunny ears. So here's the bunny ears here, here. So I put a sticker on and I drew the 3 loops in the same place that they should be. Then I did the knot notation starting at the outside of the 3rd loop. And it is actually 1, 2, 3, -3, -2, -1, -4, 5, -6, 4, -5, -6. Then I compared that to my other knot notation. Here is 33, which is this one. And here is the knot notation right here from this one when I move the loop. And if you notice, they are identical. It goes 4, 5, 6, 4, 5, 6 in the last 6 positions. 4, 5, 6, 4, 5, 6. And that looks at the gross structure of the knot. Because we're ignoring the 3 loops at the beginning, which is this. We're just ignoring the 3 loops. We're just looking at the gross knot structure. And they're identical, except for the negatives are switched. Here it's positive, here it's negative. Here it's negative, here it's positive. And I thought, well, that's clear to me. That must be one is clockwise, one is counterclockwise. So I know that 33 is clockwise because I built that one. I thought, shit, what is the imaginary knot, which I call 32 CIC? That must be counterclockwise. And it's true, it is, because that knot, the imaginary knot, is based on this little guy, which is number 20, and he's back right here. So that imaginary knot was based on this. Here we go again. We see, what if this knot loop moved inside of this loop, inside of this loop, and what if they all moved up here? We'll ignore that little guy. And it turns out that 20 is actually counterclockwise. So I'm correct. So my accurate note keeping establishes that, yeah, those knots are the same, except one is a counterclockwise and one's a clockwise. So it was the first time that I developed the knot notation, drew the knot, then built it, then compared it to the rest of my models. I'm quite pleased about that.